Welcome to the next tutorial class. So, we are doing the calculation of amplitude in the rectangular waveguide in the forward and backward direction and also calculating the input resistance. So, we have already completed this problem. Now, we can go to the next problem. Consider the infinitely long waveguide fed with two probes. So, it is shown in the figure below. So, consider the infinitely long waveguide. So, it is plus z direction and in the minus z direction it is infinitely long and fed with two probe driven 180 degree out of phase. So, we can see that one is at x is equal to a by 4 and other probe is at x is equal to 3 a by 4. So, that is feeding from the means y equal to b means feeding from the y equal to b, but one means first dipole is from feeding from the side of y equal to 0. So, both the means current is in the opposite direction on the both the means probe we can see that current is in the opposite direction, that is out of phase with 180 degree as shown below. What is the resulting excitation coefficient for the TE10 and TE20 mode? So, what are the resulting excitation coefficient, that means amplitude, what other modes can be excited by this feeding arrangement. So, for this we will calculate first the resulting excitation coefficient for the TE10 and TE20. So, here means two means probes, that is in the 180 degree out of phase and one is at x is equal to a by 4 and other distance is from the right side, it is from the a distance, that is a by 4, that means at x is equal to 3 a by 4. So, this is the third problem. So, expression for that surface current density, that can be written as J equal to, that can be written as I del z del of x a by 4, and because that is in 180 degree out of phase. So, we have to write like minus del of x minus 3 a by 4. So, like this into and direction is a by. So, it is directed along a by and this is valid between 0 to b, 0 to b. So, it is touching means to the other side from 0 to b. So, it is for, so this is the expression for y equal to between 0 to b. I del of del z del of x minus a by 4 minus is due to, this is due to the 180 degree out of phase and this is 180 degree out of phase, now it is in the minus. So, with a by. So, now modal field means that normalized field for TE10 mode means for TE10 it can be written as E1 will be a by sine of pi x by a and H1 will be minus of a x upon x this a x upon z1 sine of pi x upon a, and here z1 will be that same wave impedance for the TE10 mode. So, that is k naught eta naught divided with beta 1, k naught eta naught divided with beta 1, and because we have to calculate for both the TE10 and TE20. So, for TE20, for the TE20 this modal field will be E1 equal to, so that means m equal to 2. So, m equal to 2 means sine of this 2 pi x m equal to 2 pi x by a, and this h1 h2 will be, so this will be E2. So, for E1 that is for T10 that is E1, and for the T20 that is E2, a by sine of 2 pi x, and h2 equal to minus of ax upon z1 sine of 2 pi x upon a, and here z2 will be, means here we are noting z2, and z2 will be k naught eta naught by. So, this is the wave impedance for the T20 mode, k naught eta naught divided with beta 2, and after this we have to calculate that, we have to calculate the normalization constant, that P1 and P2. So, because P1 and P2 we can calculate, P1 we can calculate for T10, that is P1. So, that will be 2 of S naught E1 cross H1 Az into ds. So, ds will be dx into dy, and E1 cross H1. So, we can calculate that will be 2 into S naught, that a by sine of pi x upon a into minus of x upon z1 sine of pi x upon a. So, this is E1 cross H1, this is E1 cross H1 into Az into dx into dy. So, after integration it will be a by cross minus x az1, and this will be 2 of sine square pi x by a. So, 2 sine square pi x by a means 1 into a by 2 into z1, 1 by z1 into b. So, it will be a b upon z1. This is the P1 for the T10 mode. For the T20 mode, it will be E2 cross H2 into Az into ds. For the P2 for T20 mode, for the T2 it will be 2 of E2 cross of H2 into Az into ds. So, this is for the P2. So, E2 H2, then here it will be a sine square 2 pi x by a. So, again it will be sine square 2 pi x by a. So, it will be 2 integration on x is equal to 0 to a, y equal to 0 to b, and sine square 2 pi x by a into 1 by z2. So, here it will be 1 by z2 into dx into dy. So, we will get the same expression 2 into 1 by z2, and this will give a by 2 into b. So, this will be a b upon z2. P2 will be a b upon z2, and P1 is a b upon z1. So, these are the normalization factor, and after this we have to calculate the amplitude. So, amplitude of the positive travelling wave. For the positive case we can calculate as, so in the question it is positive and negative both are only positive. What are the resulting excitation coefficient for the T10 and T20 mode? So, let us calculate first for the means T10 mode and with A1 plus. So, for T10 A1 plus that is the waves means amplitude in the positive travelling wave. So, A 1 plus will be minus of 1 by P 1, this is the volumetric integral, E 1 minus A z E z 1 j e to the power j beta 1 z into dV. So, we can substitute the E 1 E z 1. So, this will come minus of 1 by P 1 minus of 1 by P 1 volumetric integral. So, E 1 will be A by sin of pi x by A, sin of pi x by A, and this second term E z 1 will be 0. So, not writing that. So, this will be, and j we have j term is I z del of x minus a by 4 minus del of x minus 3 a by 4 into a by. So, that term we can write into I of del z del of x minus a by 4 minus del of x minus 3 a by 4 into a by e to the power j beta 1 z into dx dy dz. So, for this for the first case means del of x minus a by 4. So, x will be a by 4 and the x will be a by 4. So, this will be sin pi by 4, sin of pi by 4 and minus of I upon p 1, minus of I upon p 1 into sin of pi by 4, because x is equal to a by 4. So, this term, and then in the second term means x is equal to 3 a by 4. So, we have to means we can separate into two parts, and this will be sin of x is equal to a by 4, that means sin of pi by 4, a will cancel out, and del of z, that will be z is equal to 0, that will be 1, and x del of x minus 3 a by 4. So, x is equal to 3 a by 4. So, this will give 3 pi by 4 minus of sin 3 pi by 4 into z will be 1 and y will be b, it will give b. So, integration from y is equal to 0 to b. So, this will come by and it will be b equal to minus of b I divided with p 1 and sin pi by 4 1 by root 2 minus this will be 1 by root 2. So, this will also 1 by root 2, and value for this a 1 plus will be 0. A 1 plus, this amplitude for the a 1 plus, that is 0. So, for the T 10 mode means amplitude is 0, and now similarly we can calculate the A 2 plus for the T 20. So, for T 20 that will be A 2 plus equal to minus of P 2 this E 2. So, that will be E 2 minus A z E z 2 into, so that will be j, means j. So, j into j e to the power j beta 2 into z into dV. Now, we can substitute the value of E2 and Ez2 will be 0 and J we can substitute, and after substitution it will be minus of 1 upon P2. So, this will be A by sine of E2 will be sine 2 pi x upon A, and second term is 0, I of del z and this will be del of x minus a by 4 minus del of x minus 3 by 4. So, this will come, and then a by e to the power j beta 2 into z into dx dy dz. So, same as previous, x is equal to, we can separate out in the two parts, this integral can be separate out, and x is equal to a by 4. So, this will be sine of pi by 2. So, at x is equal to a by 4, so a by 4 a will cancel out and into pi by 2. So, this will be minus upon I upon P2 minus I upon P2. So, in the previous case we can see that amplitude for the T10 that is 0, amplitude for the T10 that is 0 when exciting at x is equal to a by 4. So, that is why to excite the T10 mode we have to excite at the in the middle means at x is equal to a by 2. So, minus I upon P2 minus of I upon P2 and x is equal to a by 4. So, that will be sin pi by 2, that is sin pi by 2 minus sin of x is equal to 3 by 4. So, that will be sin 3 pi by 2, that will be sin 3 pi by 2 into on the z is equal to 0, that will be 1, on the by integral will be b. So, this will be minus of I upon P2 1 minus 1. So, this will be minus of 2 I b upon, and b is there, minus of 2 I b upon P2. So, we can see that since the excitation has an odd symmetric about the center of the probe, so it will only excite that mode that have electric field with an odd symmetry about x is equal to a by 2. So, in this case we can see that T20 mode is excited, that has finite amplitude, but when means for the T10 case that has the amplitude 0. So, that we have to keep in the mind. So, for the T10 mode excitation, when feeding at the center, then it has the finite amplitude of the means forward and backward, but for means for this case when it is at a by 2, when it will at the a by 4, for that case it will excite only the T20 mode. So, next question we can do now. So, what other modes can be excited by this feeding arrangement? So, that will be the odd symmetric what x is equal to a by 2, that will be only excited. So, next question is, consider a small current loop on the side wall of a rectangular waveguide. Consider a small current loop. So, you can see this is the rectangular waveguide and here is one loop that has radius r naught and carrying a current I naught. Find the T10 field excited by the loop. So, I have to find the T10 fields excited by the loop if loop is of radius r naught. So, find out this. So, this is the loop in the means we can see in the side wall of the rectangular waveguide, and current is I naught and radius is R naught. So, by image theory means this half loop, that is half loop. So, this half loop can be means it can be viewed as a full loop, means by image theory we can remove the side wall, and by removing side wall it will be becomes full loop, and for the full loop we can write the magnetic equivalent, means magnetic equivalent source. So, that can be written as, so Pm, and Pm is the infinitesimal magnetic polarization current. So, for the loop case means that will excite the if it is electric loop, so that is carrying current I naught. So, it can be means a dual for this will be magnetic dipole, that is in the means that is out of the loop. So, if it is loop, so magnetic dipole, that will be out of the loop, it is out of the loop. So, that will be the magnetic equivalent for this loop. For this case means Pm can be written as, that is infinitesimal magnetic polarization current. So, that can be written as Az means that is out of the loop, that magnetic source, Az into I naught pi r square, pi r naught square, r naught is the radius of the loop, into del x, and it will at the means this magnetic dipole will present at the center. So, that means by equal to that b by 2, by minus this center of the this radius circle, by minus b by 2 into del of z. So, like this Pm, that magnetic polarization current can be written, and my equivalent magnetic source will be equivalent magnetic source, as we know that J is the electric source, but M is the magnetic source, magnetic current source. So, that can be written as J omega mu naught into Pm. So, this is the magnetic current source, and j omega mu naught into Pm. So, this will be Az j omega mu naught I naught pi r naught whole square del x del of y minus b by 2 into del of z. So, this will be the equivalent magnetic source. So, M will be j omega mu naught Pm bar, this vector. So, for the T10 mode, so for T10 mode, for T10 E1 will be vector E1 will be A by. So, we have to work with the magnetic source in this case, A by sine of pi x by A, H1 will be minus of x upon Z1 sine of pi x upon A. So, that is H1, here Z1 is the wave impedance, that is k naught eta naught k naught divided with beta 1. And for this case Hz1 this modal fields can be obtained, means for the this is the normalized fields for the means in the rectangular waveguide, that Hz1 equal to j pi divided with k naught eta naught A cos of pi x upon A. So, this will be Hz1. Now, normalization constant of the nth mode, that normalization constant for the nth mode for for the nth mode. So, we know that is Pn equal to 2 of S naught. So, this will be same for the magnetic source also, En cross of Hn in dot product with Hz into ds. So, for T10 this will be P1 will be 2 of S naught E1 cross of H1 Az ds. So, this will be there. So, this E1 is sin pi x by a and H1 is minus of ax upon Z1 sin pi x by a. So, from this we will get the same expression AB upon Z1. This will come same because there is no magnetic source is here. Now, for the amplitude of the positive travelling wave, amplitude of the positive travelling wave, that will be A1 plus for the T10 mode. So, that we can write, and for the nth mode, so for the nth mode we know, that An plus for the magnetic source, that is 1 by Pn V minus of Hn. So, this is the for the magnetic source, that is different from the electric source, minus of Hn, that vector, plus Hz then magnetic source e to the power j beta n into z into dV. Now, for the T10 mode we can calculate the amplitude, that A1 plus will be minus of 1 by P1. So, here it is no minus 1 by P1 and it will be volumetric integral minus of H1 plus Hz1 into m e to the power j beta 1 into z into dV, and this will be, we can substitute the H1 and Hz1. So, equal to minus of 1 upon P1 V plus of Ax upon Z1 sin of minus H1, that means plus of x upon Z1 sin of pi x upon A, plus we have finite Hz1. So, it will be plus Az into j pi divided with k naught eta naught A cos of pi x upon A. So, this is the, and after that m, we have to substitute the m also, that magnetic current source, that is A j omega mu naught I naught pi r naught whole square into del of x del of y minus b by 2 into del z. So, this will come, means del of x is equal to 0. So, x is equal to 0, this term will be 1, and this cos x, that cos x is equal to 0. So, first term will be 0 and second term, because x is equal to 0, sin 0 will be 0 and x is equal to 0, second term will 1. So, in this case only second term will be remaining. So, for that we can write, because this is second term 1 minus, no minus 1 by P1 equal to 1 upon P1, and this first term is 0. So, j pi upon k naught eta naught. So, this will be j pi divided with k naught eta naught a x is equal to 0, this will be 1 into j omega mu naught I naught pi r naught whole square. So, this will come, and by is equal to b by 2. So, that will, there is no by term. So, this will integration will be 1. So, value for this will be, we can substitute the value of p 1, that will be a b upon z 1. So, this will be this will be j square, and j into j, that will be minus 1 minus, and k will be, and k will be that omega square root of mu epsilon. So, that we have to means do the calculation k naught. Okay. So, this is j pi, that is why. So, this is j pi. So, minus of this pi square, minus of pi square, this omega mu naught I naught r naught whole square divided with k naught eta naught a, and p 1 will be a b into z 1. The value of p 1 will be a b upon z 1. Now, we can write this like means minus of pi square omega mu naught I naught r naught whole square z 1, and in the denominator k naught will be omega square root of mu naught into epsilon naught, and this eta naught will be a square root of mu naught into a square root of epsilon naught into a square into b. So, this epsilon naught cancel, and 1 mu naught will be cancelled, and here 2 mu naught. So, this mu naught and mu naught. So, this will be cancelled, omega will be cancelled. So, final answer will be, so this is the a 1 plus will be minus of pi square z 1 I naught square r naught square divided with a square b. So, this is the amplitude for the positive travelling wave. Similarly, for the negative travelling wave, amplitude will be, for the negative travelling wave, amplitude for a 1 minus, that we can calculate. So, formula for a 1 minus is 1 upon p n. So, that is for the a n nth mode case, that is v h n, that vector, plus a z unit vector into a z n into m. So, similarly, we can substitute, and because this will be symmetric in both the direction. So, it will give the same amplitude in the negative travelling wave also. For this case also, if you will do the calculation, so a 1 minus will be minus of pi square z 1 I naught square r naught square divided with a square b. So, same amplitude for the negative case also it will come. So, we know modal field for the positive means how to write that fields in the positive and negative direction. So, that expression is E plus, that is can be written as a summation of all the modes inside the waveguide, that is a n plus E n plus, and this can be written as summation over n, and a n plus and this E n plus, and this E n plus, this will be E n plus a z into E z n e to the power minus of j beta n into z. So, for the z greater than that position of the feeding. So, like this means similar in the similar way for the magnetic field it can be means a vector H can be written. So, I means find the TE10 field excited by the loop. So, these are the amplitude. So, from this amplitude we can find out the field. So, these are the A1 plus and A1 minus. So, both are equal. So, like this amplitude can be calculated. Thank you.